This Week in Radio Tech, episode 251, is brought to you by the Axia Rack and Desk, smaller AOIP radio consoles perfect for news desks and dubbing stations, by the new Omnia 7 FM, HD, and streaming audio processor with Undo technology. Omnia 7 is a mid-priced audio processor with the sound and features you love. And by Lavo and the new Crystal Clear virtual radio console. Crystal Clear is the radio console with a multi-touch touchscreen interface. Many households in rural areas are still not served by cable internet or DSL. Radio engineer Patrick Parks wanted better internet service to his country abode. His efforts led to building a wireless internet service provider called SmartBurst. Pat joins Chris Tobin and Kirk Harnack to tell us how it works. Hey, welcome in. It's This Week in Radio Tech, episode 251. I'm Kirk Harnack, and there's a beautiful shot of downtown Manhattan. We can go ahead and keep that shot. That's fine. While I intro the show, I can talk over downtown Manhattan. That's fine. Hey, this is the show where we talk about everything in broadcasting, from the microphone to the penthouse in a downtown Manhattan apartment building. Yeah, and everything in between. And in fact, we've got a subject that's going to be of real interest to folks who live out in the country and maybe some who live in the city, and that's wireless ISPs. So hang on to your hat for that. Plus some RF stories of troubleshooting 1,000 feet in the air. It's going to be a good one. Our guest is Patrick Parks. We'll get to Patrick in just a second, but let's bring in the best-dressed engineer in radio. It's Chris Tobin. Hey, Chris. Hi.
Hello, Kirk. Yes, I'm outdoors today. It's springtime. Well, it's almost spring. I guess another day to go. So, enjoying it. But again, tomorrow is going to be stormy weather, so today's the only good day we have. And have my cannoli and a cup of Irish coffee, and I'm doing well.
Leave the gun.
That's right. Leave the gun on the table. Always take the cannoli.
That's right.
Matter of fact, it's 25 years this year. It's an anniversary for that show.
Is it really?
Yeah.
Was that line from The Godfather 2 or the first Godfather?
Goodfellas.
Oh, Goodfellas. Neither Godfather. Some Goodfellas.
Right. Same, okay. Similar part of the world as far as the heritage.
All right. Hey, Chris, your expertise that you bring to the show comes from many years of broadcast engineering, and lately you do something that is helping a lot of folks out with the newest technology. Tell us what you're doing now and how you're helping broadcasters.
Well, right now I'm doing work with a lot of IP-related stuff, audio and video. And matter of fact, today I was at a site survey for a sports broadcast I'll be doing this weekend over IP, wireless IP, using a brand product called Redline, 5.8 unlicensed microwave, I guess you call them, Ethernet bridging. So it's going to be fun. Non-line of sight, though. They're not going to look at each other. They're going to bounce off buildings to make it work.
Really? Okay.
Yeah. Well, it worked today. We'll see what happens on the day of the broadcast.
I'm glad we've got Patrick on the show. Let's bring in Patrick Parks. Patrick is a fellow who I used to live in Dallas. In fact, not terribly far from where Patrick is. He's out in the country. I lived in a suburb. And Patrick Parks is chief engineer for the Univision radio stations in the Dallas area. But he also is El Presidente of a wireless ISP that serves folks who probably have a hard time getting internet otherwise. Welcome in, Patrick. Are you there?
I'm here. Hi, Kirk. How are you?
Hey, there you are.
Yes, hello.
Glad you're along. Patrick, did we didn't meet when I worked for Scott Studios in Dallas, I don't think. I think we met when I first started working for the folks at Omnia. I probably visited you with an Omnia processor under my arm and said, hey, you want to put this on the air?
You did. You did. In fact, I believe that may still be on the air on one of the stations.
Oh, my goodness.
Wow. Very good luck with them. And all the software updates, we've just been very happy. No reason to change.
Well, cool. So Univision is like your day job, and we're going to have some stories about that. You've got some fantastic pictures of a failure on a tower. So we're just going to leave it at that, and we're going to get to that in a bit. But we're also going to talk about your founding and running of a wireless ISP. And so hang on to your hat. We're going to get to that. We got to do a real quick commercial here for the folks who help pay for this show and make it possible. And the show This Week in Radio Tech is brought to you in part by the Telos Alliance, and specifically by Axia, and a couple of really cool audio consoles that Axia makes. Now, I thought I'd talk about these a bit more today, because I just saw a picture from a brand new multi-studio installation in San Francisco. The Cumulus stations there have installed in their news gathering area a bunch of these small audio consoles from Axia. I'm talking about the RAQ. That's the RAQ. Cute name, right? It's kind of like the IKEA spelling. The RAQ, rack mount IP audio console. There's a picture of it right there on screen. This is a control surface. There's actually, no audio in the console itself. The electronics, of course, are elsewhere, and they can be in a rack mount box that uses either the Core 16 or the Core 32 DSP engines. And of course, it's all hooked up by live wire. So that means that the amount of wiring in a studio where you have one of these consoles is completely minimized. You don't have big cables getting audio in and out of the room. And even from that room, from that studio, you can send your audio anywhere else on the LiveWire network. And of course, you can bring in sources from all over the place. If your hybrids or codecs are located back in a rack room, or you want to bring a live mic in from a studio next door, no problem. It's all on LiveWire. It's all on the network. Now, I've got one of these rack IP audio consoles at one of my stations. We put one of these in for our newsroom in American Samoa. And it has been absolutely fabulous. Until we got this console, we had all the usual problems that you have with an analog console. And, people moving stuff around, plugging and unplugging cassette machines, or I guess they have flash recorders now. And just all it's a newsroom, right? So there's papers and pens and just junk that gets laid everywhere. And it seems like every time I went to American Samoa, one of the first things I had to do was find the hum in the news audio console. Find this problem or that problem, or my headphones don't work, right? Whatever it was. And the rack console has totally eliminated service calls. Now, I'm not saying it'll never fail, but I'm just saying that the way that you hook up stuff to the rack and then the way it uses audio and controls audio makes it much less likely to be failure prone like analog consoles of old have been. In fact, let's take a look also at the rack's big brother, or I guess brother, the Desk, DESQ, the Desk console. This is essentially the same thing as the rack, but instead of little rotary knobs for your volume, it's got linear faders like the rest of the consoles in the Axia line have. So the rack and the Desk, they're both essentially the same except for that fader style. You can do all the usual things that you do with an Axia console, like automatic mix minus. That's right. From every news desk, you can have automatic mix minus feeds going on. So when you do a hybrid or a codec remote, no problem. The party on the other end hears exactly what they're supposed to hear without any thought or intervention from the from the news reporter, or if you're in a small studio, from the operator of that studio. Of course, the rack and the Desk are part of the much larger Axia product line. They plug into the LiveWire protocol, and they connect to everything else that speaks LiveWire, which is close to 100 products around the world now. It's just amazing stuff. So if you need a small console, check this out: the rack IP audio console from Axia and its brother, the Desk console. I use it, and I really believe that you will like it too if you have a need for a small console. All right. Let us jump into our show here. Patrick Parks is our guest. Chris Tobin is along with us. We're talking, first of all, wireless ISP. And Patrick, how in the world did you get into that business? And I got to tell you, it crossed my mind about 10, 15 years ago that might be an interesting thing to do in areas that were getting poorly served by other traditional internet providers. What got you interested in the wireless ISP business?
Well, Kirk, we struggled with dial-up like so many people did. Probably, 2000, 2001 when we got out here. One of the things I was charged with was finding a site to build a 1,000-foot tower for an upgrade for one of the stations for Univision. It wasn't Univision at the time, but became one of the Univision stations now, part of the 5-station cluster that we have here now. We struggled with that for a couple of years, and then I would go over to the building next door. I have a tower that's partially on some property that I have out here, and use the internet. And just because it was difficult to dial in and VPN in and get anything useful done. And after doing that a while, I found a way to build a wireless bridge, just off the shelf stuff. It was a company, I believe, the name of the company was BreezeCom. Just integrated 802.11 panel antenna and radio in one. It only had to go about 1,000 feet. Okay. So that got our wireless connectivity going. And,
now, that was from the tower site that you live near to your house, right?
To my house, that's right. And it was really just for work purposes.
Less
And
than a quarter
so I had a fellow broadcast engineer visit once, and he said, "How do you get good internet like this out in the country?" And I told him the story, and he said, "You know, you got this big tower here. You should put an access point up there and sell it with your neighbors. Recoup the cost of your T1." And I was like, I don't do that. I'm a broadcast engineer. I keep radio stations on the air. Don't have time for that. Right. So a year or so went by. I'm not exactly sure how long. And we did decide to experiment with it. Talked with our director of engineering at the time. And across the highway is about 50 residential homes and little neighborhood there that in the same predicament. And as we made friends with some of those people and word got out, they were basically banging down our door to get this thing built. So
you have internet? It's in the air?
That's right.
How do I get me some? So okay.
Go ahead. Go ahead.
Well, so
it kind of worked right out of the box.
Now I'm betting that the technologies and the equipment that you're using today, years after starting this business, are different than what you started with. So can you give us a real quick description of what you got started with equipment wise, how maybe insecure it was, or what you realized, we got to improve this, and then take us into how how that worked out and how the technology was when you started.
Well, there was a lot less stuff available than there is now. It was all 802.11 stuff. Most of it still is, but there's a lot of other platforms that we're now looking at and beginning to deploy. Others are deploying. Basically, it came down to capacity. That's where WISPs are evolving, because we're having to carry a lot of the traffic for. I saw a spec the other day, a stat the other day, that 50% of the internet traffic is Netflix and YouTube. And I think that's a reliable stat. I've definitely seen it on our network. But we started very basic. I didn't invest a whole lot of money in the infrastructure in the beginning. There wasn't a need for that. We weren't trying to serve 3,000 customers or anything. We were talking about the ranch and some houses across the street. So it just evolved from there. I didn't write the book WISP for Dummies, but I've just kind of learned my own way. What works for me may not work for others. I've met, like in broadcast engineering, I've met a remarkable number of people that are willing to help you, tell you what they've learned, what they've done wrong, what they've done right, and that's been a big help to me. Constantly stay up with the trends and the mailing lists, and attend training that's available. But, we started very small, like I said, 802.11 stuff, added access points, found that as we added customers, here's an interesting thing. We had at one point, I believe, 40 or 50 customers on a single T1. And this was probably, I'm guessing, 2006 or so. And not nary a complaint about speeds or availability. And we started seeing traffic increase quite a bit, and we just determined, we need to add some bandwidth, which we did. We added more T1s, began to bond more T1s together, and ran out of facilities. The phone company just didn't have the pairs to get any more than about 5 meg to us. And we began to tap that out at about 100 or so customers, and it became I began to see more YouTube stuff. It was mainly YouTube, and then Facebook was coming along, but we saw Netflix coming on the scene, and that's when we had to bring in some bigger pipes. And that's the biggest challenge, I think, to starting an ISP is do you have big pipes available? If you don't have them very near, can you get them backhauled in? That's what we have to do.
Let's talk for a minute about the tech of the 802.11 gear that you started with, and what you learned about the RF and the rules of thumb that you have there. I'm a little confused about this. Let's say that, I've heard of some high power access points. So you've got an access point on the tower. I'm assuming some kind of commercial grade antenna, an Omni, or maybe whatever it was. And even if the power of those is high relative to a home router or a Linksys router or something, what about the return path? And how's the signal levels of the customer's radio, whatever it is? I guess it's outside, and your access point on your tower.
Okay, well, it depends on what band you're on, Kirk, but basically most stuff is limited at point to multipoint. That is, the access point on the tower to the customers is limited to an EIRP of about 4 watts. That's it's 36 dBm. And
that's the access point. What powers the customer's radio?
They have I think the limit is 250 watts. I think it's 53 dBm or something like that. I don't keep track of all these numbers, but something in that area. So they can operate at a higher power level, and you can use high gain dishes, and they're down low, so they're not subject to interference. So the access point is, I've discovered there are basically four variables to deal with with an ISP as far as the physics. You've got line of sight. You need to have that to a customer with the frequencies we operate with, unless you're at 900 megahertz, and we do a little of that, but there's not a lot of capacity there because there's not a lot of spectrum and the interference is high. There's interference to deal with. There's spectrum rules, which is a whole conversation I could go on about an hour right now, and basic physics. And basically, two of those are known values, meaning that you have to solve for the other two variables. Line of sight's a known quantity. It ranges from virtually nothing to 100%. If it's compromised, it's either a structure in the way, vegetation, some type of ground elevation issue.
Yeah.
So we've got a lot of data available for looking at basic physics and line of sight from the space shuttle, the shuttle radar terrain mapping project. There's a lot of data available to us there, and tools that are available to us to tell a customer whether we can give them service or not. But we like to tell them, can you see the tower? Can you that's a good start. If they say, well, I can't because I can't because there's a tree, and then we say, well, do you have a spot on the property where you can? We can go through some vegetation. That's not an instant deal breaker, but it weeds out a lot of customers if we can find out how far they are from the tower and whether they can see it or not. So those are kind of the four things: line of sight, interference, the FCC rules, spectrum rules, and just basic physics. And so you asked about how we started. It was basically off-the-shelf 802.11 stuff. We looked at some other hardware by a manufacturer that had kind of blazed the path in making 802.11 stuff more. Because 802.11 stuff is really not meant for big distribution, big point to multi-point. I mean, it was really an access point in a building, in a room, talking to laptops who all could hear and talk to each other. So we knew if the spectrum was, if the medium was being used or not. And these clients at homes maybe 8 miles apart, you don't have that. So there's a company that basically went in and hacked 802.11 in. 802.11 in, first off, has more capacity because you got two streams, multiple memo working for you. And then you've got they kind of hacked it. They got rid of the carrier sense mechanism, so it doesn't listen to the carrier, to the medium, to see if something's working. They just allocated everyone a time slot, so it's basically TDMA. It's not true TDMA, but it's close.
Yeah.
So we know where every client's going to be, when they're going to talk. So this was able to increase throughput and whatnot. And now that same company is working on the 802.11 AC standard, which is going to be 4 spatial streams. So that's another increase in throughput. The challenge here is, as you increase you add spatial streams and you add data rates, you're getting up, some of this stuff is running 256 QAM. You need a really quiet channel to be on to get the kind of throughput. So there's again one of those variables factors in there. It's it's a little bit like a Rubik's cube. You solve it one side, and then now you got to turn it the other way. So
you brought up a subject. I want to return to it later on, and that is about 256 QAM and what QAM is and how that affects your symbol rate and the sensitivity, robustness versus throughput. We'll get back to that, but I want to ask you. You mentioned a moment ago. You mentioned the word security, and I want to try to understand a little bit. Or sometimes we're told by these security podcasts, hey, don't be on hotel Wi-Fi if you got something sensitive to do. Don't even be on a hotel's wired, because it probably just goes to a hub where everything is shared. In the 802.11 world and in the schemes that you have now, is it possible? Is it likely? Is it unbelievably difficult for one neighbor to latch on to what another neighbor is doing if they're both customers of yours?
Well, they can't get on our system easily. I'm not going to describe exactly the security we're using, but it's the most robust and the most secure that's available commercially. Yeah. And it's actually approved by the Department of Defense for top secret documents and whatnot. So That's the type we're using. The client himself has to secure their router. Now, we don't provide routers, but we require them to secure it, and we usually do that for them at the time of installation. So, anybody can attempt to hack anything, but we have never had an intrusion. We don't expect really to have one. There's a couple of other layers of security besides just encryption and having the right key that we employ. So there's quite a few hurdles to get over. I mean, at the point you're trying to hack into something, it's like being in front of somebody's house. You're going to have to be there a while, and someone's going to be asking some questions. Why are you here trying 10,000 tries or whatever,
So in the 802.11 world, in Wi-Fi, does there exist the concept of VLANs? And if so, can you use VLANs to segment customers away from each other to some degree?
You can do that. You can also do stuff with subnetting to keep your business customers separate, or just keep certain servers in their own subnet. If something goes rogue or goes crazy, your whole network isn't compromised or come bottlenecked or crashing down. The VLAN really isn't. Wouldn't say that it's specific to 802.11 stuff. I mean, again, that's just a standard for transmission, for wireless transmission, and that's going to be more
packet tagging. That's right.
Yeah, exactly.
Yeah. Okay. Cool. Wow. Okay. Hey, Chris Tobin, I know he's standing by. If you got some questions, man, hop right in. I'm curious, Patrick, now about where you've moved to. Surely you're not using the same gear that you are using when you started, or maybe to some degree you are. Where does your industry of wireless ISPs? What are some of the cool things that are happening now that wireless ISPs are installing or have in place at this time?
Ooh, cool things. I guess that's subjective. I mean, from a nerdy point of view, there's a lot of neat stuff coming out from vendors and appliances, which helps manage bandwidth, helps manage some of the challenges we have providing video to people. We're having to carry the water for all these people. In the old days, the TV networks, the satellite guys, they built their own infrastructure for delivering this content. Well, Netflix discovered the internet, and hats off to them. And here's a highway built for them, but bandwidth is finite regardless of how much you try to build out, and it has to be managed. And there's just a lot of tools coming out now, a lot of stuff that'll help you manage that. Billing and customer service products that are coming out, and it's been happening so fast. I mean, we've kind of just been, for lack of a better phrase, kind of kludging stuff together. I mean, I don't want it to sound hokey or unsafe or not professional, but it's things have happened so fast. We haven't really want to get married to any particular vendor on any particular. I mean, our core router has stayed the same for basically, at least the vendor has stayed the same for the past 10 years, and we've stuck with the same radios now for about the past 5. We do have some original legacy products still in service for people that are on, grannies checking their email and whatnot and don't need, anything more than 1.5 meg or so down. We still use those, and we're weaning people off of that. If people upgrade, we'll move them over to the new platforms. But that's infrastructure that's in place and paid for, and still generating revenue and providing good service to people. So we're not. It costs to go up there and yank it down, and then we have to do something about going ahead and moving the people. So we're moving them as they upgrade or another need comes along. It's a testament to some of the equipment, though, that it's been in a harsh environment for almost 10 years and just keeps on ticking.
Wow. Chris Tobin, what do you have in your neck of the woods for wireless ISPs, if any?
There's a lot. I was just looking them up a couple of weeks ago. I know in one of the outer boroughs in Brooklyn, there's one in the Park Slope area. There's a lot. Part of the problem I've run into talking to folks in the WISP world is a lot of the local, the franchising, the licensing or zoning, whatever you want to call it, and getting into some neighborhoods, and the pushback from the other internet providers. I know here in New York City, there have been several pushes to try and allow buildings similar to like what I'm in to do their own WISP approach, to contact somebody, and there's been pushback from the local phone companies or local carriers and claiming all kinds of infringement. But there's a lot. I mean, here in the city, there's a lot. For business, there's a lot of WISPs between a lot of buildings. I know a couple of companies I've worked with. Matter of fact, I'll be doing some work tonight on a building, replacing 2 antennas for that purpose. And it's interesting. On the business level, there's a lot. Residential, they're starting to pick up, but there's some pushback. I don't know if it's the same for our guests, but it's interesting some of the things I hear about outside the technology side of the WISP.
Chris and Patrick, for years, I had a access to a couple of nationwide ISPs, and I never got a bill. They're my favorite ones. There was one of them company was called Default, and the other one was called Linksys, and I had access in a lot of places, and it seems to be all protected now.
That's so true.
That thing caught on. That internet thing caught on.
Yeah. Oh gosh, what was I going to ask next, Patrick? Patrick, if you could tell me a bit about at your transmitter site, your antennas are obviously high enough to provide the coverage you're trying to provide. Are the electronics all up in the antenna? I can't imagine a 2.4 gig or 5 gig or whatever signal going a long ways up a tower through coax. How is this laid out?
It is. It's all power over Ethernet, PoE. And that's for the. We do have a couple of licensed links that are not. They use an IF cable and they have a separate outdoor unit for that. But the basic stuff for the customers, it's very simple. It was surprising. I kind of took my knowledge of broadcast engineering, RF, towers, antennas, and in-house networking stuff with cabling and switches and building an indoor or house network, and kind of put that together with what this WISP became, and so it was interesting to find what manufacturers were able to do, what they're able to put in a little box. You look at it sometime and go, are you kidding me? I'm gonna put this on a tower? Is it going to hold up? But it does rather well. And failure rate is low. If you do your grounding properly, if you install things properly, weatherproof your jumpers if you've got them. If you've got RF jumpers, I mean, sometimes you do, sometimes you don't. If you have an integrated antenna, you don't. But most of them don't. At least on the access point, the clients are all integrated antennas, so there's nothing really to weatherproof. But nonetheless, it's all self-contained on the tower. PoE, you can run up to 100 meters or so. We have some access points that run more than that, so we're running fiber, and then we have a separate source for the power, either 24 or 48 volts, depending on the vendor.
What would necessitate having more than 100 meters of cable at a customer's location? Antenna placement? Possibly,
yeah.
Okay.
Yeah, sure would. If they didn't have a line of sight, I've had customers that want internet so bad they're willing to pay extra, or we don't do it anymore, but they'll go get a contractor to trench a cable X number of feet, or put in fiber, or put in a wireless bridge. I've even had them put in wireless bridges from a barn or a workshop or some other point on their property, so that they can get broadband back to their home.
Gotcha.
Hey, Patrick.
Go ahead.
Sorry,
yeah, Chris.
What type of antennas? I'm curious. Do you use sectorized antennas on the tower for, reaching out to your customers?
Generally we do, Chris, and it's easier to manage the interference that way. Put more customers on a system that way. Like manufacturer, for instance, will recommend and say, our access point will handle 100 customers. Well, yeah, 100 can connect to it, but you don't want to load that many up. So if you got a tower and you put up 3 or 4 sectors and you do 30 or 40 per sector, I mean, there's a site that can serve 120 or so customers. You get on a couple different bands, you can even bump that number up a bit. We have used Omnis. We have one site we do use an Omni right now. It's a water tower that doesn't serve a whole lot of people. It's got some growth potential, and so we started out with just an Omni there, and there's no real interference problem. But generally, we do use sectors for the reasons, including subscription number and interference and management.
That's a great question. Yeah. Hey,
the reason I asked is because I was on a rooftop a couple of weeks ago, checking out some antennas that were being used as a sector arrangement, and the height we were at, the location, the angle, the beam tilt. It was just fascinating to see that this actually worked as well as it did at the power levels that they had to operate with. So I was just curious.
Yeah, absolutely, and that's key. I was surprised that it works as well as it does with what power we're limited to. And there could be another discussion. May not have time today. The FCC's released some more spectrum to us, but they've also implementing some new out-of-band emission rules for the manufacturers to comply with, and a lot of them aren't able to do that. So they're just pulling back the power. So our ability to use to continue to use like the 5 gigahertz spectrum effectively is I think being threatened. But yeah, you may see some sectors that may have some add-on kits of a lot of aluminum. A lot of the people would try to locate these sectors real close together in the front to back ratio, even if it was advertised to be X number 25 dB or whatever. Found out in practice that wasn't a real good thing to do. So radios were self-interfering, and there's companies that have grown businesses of their own. That there's a company that makes what's called RF armor, and it's used to cover up, increase the front to back ratio of the antenna. It covers up the radio itself so that it does its EMF shielding basically, and but yeah, if it's installed properly, it can really work. There are some people that struggle with that though. A lot of guys that have no clue how it technically works and have a real tough time with making it fly.
Wow, good question. Good subject too about that the sectorized antennas. Help me understand on a sectorized antenna system. Do you have one radio per antenna, or is one radio
Correct.
Feeding several antennas?
Yeah, you have one antenna per sector. Yeah, I mean one radio per sector. Yeah.
Okay. Okay. So it's like different systems, each with its own just little portion of it. Yeah, and how are the sectors typically 90 degrees or less?
90,
or more?
120, 60. I've seen. I saw an install once where there were 6 60s. That was interesting. But you can have 4 90s, 3 120s, any number. It was funny. Our first one we put up 2 radios on 2.4 gigahertz back when you could use that, and they were 2 180 degree sectors. In fact, I still have those antennas. They're down in the shop somewhere, and I saw someone the other day that was looking for them. So I'm going to see if I can't find that. Maybe someone trying to start something. We have absolutely no use for them, so may donate to a cause or whatnot, but so any number that works up to cover a 360 degree area, and maybe you don't need to cover 360 degrees, so you don't necessarily need to do that. But if you want to have the effective coverage of an Omni, then you need whatever number of those beam widths to cover.
Hey, you are watching This Week in Radio Tech. I'm Kirk Harnack, along with Chris Tobin, and our guest is Patrick Parks. We're talking about wireless ISPs. And when we come back from this commercial, we're going to ask Patrick about what does he do at 7 p.m. every evening when people plop down in front of the TV set and want to watch Orange is the New Black, or whatever they're going to watch on Netflix or Hulu or YouTube. That's when I see bandwidth consumption really going up. Is 7 to midnight. When I asked Patrick about how he handles that, and also coming up, we've got some great pictures from the top of a tower, 1,000 feet up, where a major problem occurred and how they found it. Hey, our show is brought to you in part by our friends at Omnia and the Omnia 7 FM audio processor. Let's see, the Omnia 7, what can I say about it? It is high performance at a really affordable price. And I mean down well under $10,000. Like, I think it's under $7,000. Maybe it's under $6,000. It's in that neighborhood. I didn't know last week. I should look it up, right? I work for the company. The Omnia 7 it's like the little brother to the Omnia 9. There's a few features that it doesn't have, but it's got the processing power that you want. So where you want it on the FM, and if you want to optionally add HD processing or RDS data generation on it, you can do that. One of the things that the Omnia 7 has that everybody loves is this undo technology. Now, if you watched our TWiRT show a few days ago, then you saw Hans von Supten, a few weeks ago. Excuse me. Hans was on the show with us, and you heard him talk about this undo technology for restoring audio where it had been clipped off. And it's amazing how it makes the audio sound. You can have songs that you've been playing for years that you knew were clipped and didn't sound good now sound really good on the air. So it's got the undo technology. It has the psychoacoustically controlled distortion masking FM clipper. I can't memorize that. I'm reading that. Plus, it has a 2-band final look-ahead limiter for HD radio and for streaming. And it's got the full Omnia toolbox of things that help you visualize what's going on with your audio. The digital oscilloscope that you can put on either left or right input or left or right output. It has an FFT spectrum analyzer. Same thing, you can spectrum analyze input or output audio. And a real-time analyzer as well. third octave real-time analyzer. It's really great. And this has been built into the Omnia 9 for years now. Now it's built into the Omnia 7 at a much more affordable price. It has a new feature called the Wet Voice Detector. And the Wet Voice Detector detects speech even over music and applies the right processing algorithms for that speech so it sounds good as the music fades away and you got speech by itself or another song coming up under it. Talking over a music bed, for example, works great. Here's something else interesting: a built-in speaker calibration tool. Have you ever wondered, are my speakers flat? How do they sound in this room? Well, the Omnia 7 has this built-in tool to calibrate those speakers. So many other features: multi-band downward expansion, which does source noise reduction, and a three-stage wideband AGC with adjustable sidechain and equalization. It's feature. So many of them. Check it out on the Omnia website. Go to telosalliance.com, find the Omnia logo, and click on the processors, and then you'll find the Omnia 7. The good news is it's shipping right now. It's been in prep for, well, it seems like forever, but it's shipping now, so you can get your hands on one. I'm going to get one for my radio stations. Check it out, Omnia 7. Thanks so much to Leif Clayson and Frank Foti, Mark Benolio, Rob Dye, the whole crew there, who put their brains together and bring us these fantastic processing products. Thanks, Omnia, for sponsoring This Week in Radio Tech. All right, coming up now, Patrick Parks is our guest on This Week in Radio Tech. Chris Tobin is along with us. And Patrick, let us talk about the maybe I'm calling it wrong or making it up, the 7 p.m. factor. What happens when the bandwidth at everybody's homes goes way up?
You do have to have good networking principles, or it won't. I mean, that's the key. I mean, I couldn't do all of this with the few number of hands that I have in order to keep it all the plates spinning. And it pretty much, you buy the right equipment, you install it properly, you stay on top of it occasionally, look at things, pay attention to any notices you get, set up proper network monitoring, and have the tools in place to let you know if you have a problem.
So when you're monitoring your network, what kind of things are you looking for that would say, oh, that could be a problem?
Oh, if you really want to drill down, you need to, and that's the number of connections that somebody might be opening up. And that's not just that term means number of in there. Depending on what application they be running, they may be having to open up a lot of IP connections to particular servers in order to get the content. It might be a torrent, a BitTorrent running, or a video conference or something, like any number of things it could be. But really, Kirk, it's really like a well-run radio station if it's built right, and you don't even need really well-trained people, but you need a good automation system. And if it's done right, it basically just runs. You need to look at it occasionally, like I said, but it really just runs. I mean, there's no moving parts. I mean, we did have a core router that was based on a PC, and it had a spin drive in it. And about 3 years in, that spin drive gave up the ghost. So we replaced it. Replaced it with one that has an SSD, and that's not going to be a problem anymore. But I mean, there's no moving parts. But you do look for excessive bandwidth consumption. It is all unlimited. That's our name. We're not going to say, hey, you're reaching your cap or anything. But we do have a quality of service policy, and we do let people know, hey, if you're causing a nuisance on the network, we're going to have to talk. And we really haven't had to do that. The customers are great. They appreciate what we have. And we've got adequate bandwidth to serve right now. There are times, you're right, though, the 7 to 12 p.m. time frame, you definitely see a big curve there. The business customers you'll see during the daytime, but not to the degree, because generally people aren't sitting there watching Hulu or Netflix or whatever at work, and they're not supposed to be.
Not supposed to be. Hey, Chris Tobin, you've got a question.
Yeah, I have a couple, but I'm going to start with this one. I'm curious. In the WISP world, or the ISP world, since you're from the broadcast side, you know that part of things. In the world of determining pricing, I recently was talking to a WISP about an idea, because I was working for a radio station and we were doing some remote broadcasts. And when I saw the network they had, and the points of presence, and how they have everything laid out, I was like, wow, you have POPs in places that make sense for some of the broadcasters in the market that can actually be doing wireless to, I'll call it wireless, connections and doing remote rather than contacting the local phone company for a dedicated line pair, the usual old-fashioned stuff we did. And when they came back to me with pricing, it was like as if I was putting in for a month's worth of connection when I was just looking to do a one-day hit. I know there's tariffs in certain industries and certain parts. I'm not sure where the ISPs fall into some of the tariffs that are out there. But, it just didn't make sense. When I did a business plan, I looked down, it's like, wow, this makes total sense. I presented it to these guys, and they were like, yeah, no, we have to charge this because that's just the way it's set up. And I'm like, at $5,000 a hit, that doesn't make any sense. What are you trying to do? So I'm just curious, how does that work for that industry? I mean, without, of course, giving away, secrets and stuff. But just curious.
Well, Chris, I think it's the inkjet cartridge syndrome or more model.
I thought so.
We'll say that we'll give you the printer, but we want you to come back every 35, 40 days and spend $50 on cartridges. I think that's how a lot of operators work. We looked basically, as I was telling the story in the beginning, that we just wanted to recoup the cost of the T1. Cost of bandwidth has come down. Some other expenses have gone up. I've had to pay more for tower rent as we add more antennas, having to have more sites, put in more micro pops. The model kind of changes. I can't say how everyone prices. We look at what we have. Two competitors here now. We had barely one when we started. We have not lowered our prices, but we haven't raised them either. We have offered some packages that we didn't offer back when we didn't have that kind of bandwidth, which we charge more for, but the cost per bit has actually gone down over 10 years. As far as tariffs, there are none. I mean, there could be in different states. I'm not aware of. There's nothing in Texas. There's state sales tax, and it's only 6% on 6.25% on any amount over $25 a month on internet access. So in that particular situation, we're just trying to rent one for a day. I don't know how many models exist that would really support that at a price point that would make sense. I mean, if you're going to go, and you're going to go get a T1 for, even if it's just for a day or an ISDN, you're going to pay the full install and a full month, even if you use it for a day. So
it was still cheaper doing the T1 than it was going to the wireless guy. That's the part I was trying to figure out, and I explained to him the whole industry and the way it's set up. And their markets included Chicago, New York, Hartford, Boston, a couple other places. I said, look, there's a few networks that I could hook you up with, and we could probably come up with a plan that makes sense and everybody benefits. It just didn't click.
I think I know who you're talking about.
Okay.
Kirk, back to you.
Yeah, I was muted. Hey, I'm curious again about this bandwidth thing. Okay, so you don't have caps, and caps and bandwidth are related, but they're not the same thing, of course. Here at the Harnack house, we're on Comcast. We have a soft cap of 300 gigs for a month, and we blow through that every month. Some months we've used 500 gig, but we got kids watching TV, and I got to find this. I got a program on my computer that backs up anyway. And it no longer gives anyway. I got to find where that's going, but and so they charge another $10 for 50 more gigs and $10 for 50 more gigs. Yeah, actually, to me, that's really reasonable because for the normal price, we could watch plenty of TV. I may have an abusive program on my computer that backs up chunks of 40, 50 gigs at a time, but. I'm curious as to how you actually handle this in the wireless world. I would think that in wireless you've got a much tighter constraint on your overall bandwidth out there, at least from a given tower site, than you would in the cable modem delivery world. What are typical speeds that your customers get, and what kind of tiers do you have? Well, for residential, our max is 12 meg down, 2 meg up. And that's not available everywhere, but it's available in a large number of areas. Businesses, we can deliver whatever you want. You're ready to write the check, cover the cost of install in a long-term contract, whatever. And we can deliver whatever you want. But the basic boilerplate stuff is 8 meg down, 2 meg up, 15 down, 5 up for business. And you get a static public IP address with this. I was just looking here at some current stats. We've got a customer, the largest customer this month is a residential customer who, as of the 19th, has consumed 430 gig of data. And the next closest is one at 250 gig.
quite a few in the 200s, quite a rest in the hundreds, and then much fewer after that. But in the wireless world, what we got going for us is we don't. You probably have a 50 meg connection or something, don't you?
Yeah, 50 down, 10 up.
You know, it's easier for them to deal with that. Yeah. As you add customers, you have to find out what their usage habits are going to be. You have to do. We've got kind of overlapping sectors. There's all kinds of tricks you can do to try to find out who needs to be where, who's going to cause a nuisance on the network. If they're getting their content, you know, if they can stream at 5 meg, even if they're subscribing to 12 and they can stream at 5, they're likely still going to get HD quality. I think that's where people are not going to complain. So we don't limit, but there's going to become a certain reality at certain times that some people probably aren't quite getting that. They understand that the contract explains that, but we don't purposely limit them.
Yeah.
You know, it's a challenge. It absolutely is. I would love to be able to offer. I mean, we're taking a serious look at LTE and deploying that. The equipment right now is real expensive, but there is a vendor that's catering to WISPs, and it just does some remarkable stuff. Totally breaks away from the 802.11 model and can do remarkable things. I mean, very similar to how, you know, you can get one of these gadgets here and get, you know, 50 meg download.
Yeah, incredible speed.
I mean, it's remarkable. Of course, you've got, you know, preamps up on the 20 dB preamps up on with the radio at the antenna, and you got, you know, a third of a watt of power here in the handheld, but it works. So we're looking at that. So it's you're asking good questions. It's just we're still evolving. We're still learning. I mean, this whole carrying video has changed the entire dynamic. You know, like I said, 9 years ago, we're running 40 customers on a T1, and everyone's happy as a clam. And now, you know, it's a struggle to keep going with what we've got. But again, lots of sectors. Micro pops, you know, we started with one big tower, serve a big area, and we kind of scale that back now, and we're putting in more micro pops, more stuff from people's rooftops. That means more backhauls or another way to get the bandwidth to that site. But you kind of start divvying it up. You have
that would be a lot like the cellular industry. You got too many customers in an area, add a cell.
Yeah. You remember when cell stuff started in the old 800 band or whatnot, and you would routinely see 250, 300-foot towers, right? And there might be one or two in a decent-sized town, mid-sized town, and that was kind of it. You might see one along a highway. But now you see monopoles everywhere. You see stuff on power poles. You see stuff that's camouflaged, a flagpole or a tree. They're all over the place. So it's that model has really been what they determined we're going to have to do to serve this number of people. But again, you know, if you pick up your phone, everyone got on their phone or tried to make a call, you know, they're not going to be able to pass the traffic to everyone they handed a phone out to either. So there's a number there. There's a function there, some formula that so that they can oversell to, and we do as well. We know, and that's another thing. We look at our graphs. We look at what people are doing. We've negotiated new deals on bandwidth kind of ahead of the curve, and I was telling someone the other day we were bumping up about 90% of capacity, and it really surprised me. We'd had an ice storm, and I was like, aha. Not just are people home not working, but people are bored. People have got cabin fever after 2 or 3 days. I was kind of scratching my head, what's up with this? And that's what that was all about. So I didn't run out and buy, you know, another 100 meg of data or whatever, and try to find a way to get it in here. So we, you know, that was a little anomaly, and you know, we just continue to watch things and learn.
I wish we had more time. There's more on this subject that I want to talk about, but I promised everybody we'd move to that RF subject because I found this to be fascinating. And so, Andrew, if you've got some pictures ready to show, that would be great. Patrick is, besides founding and running this wireless ISP, he's also the director of engineering for some radio stations in Dallas, the Univision stations. And hey, I used to live in the Dallas area. They got some tall towers around there, and tall towers means you got hardware way up there where it's hard to get to. You can certainly hire tower crews to do it, and you do what the troubleshooting that you can. You do it from the ground when you can. So, Patrick, why don't you kind of set this up? Tell us what the symptom was, and then we'll see if I can get our first picture up with the picture of how you troubleshot it.
Well, you're spot on. We're really spread out here. Big area. There's Dallas, there's Fort Worth, but then there's another 100 towns making up the area. And we have 5 stations in 5 counties with 12 towers and about 300 hours of windshield time. And I always have to laugh that when an insurance person or a risk manager come to town and they'll phone up and say, I need you to take me to all your sites. I'm getting in at my flight gets in at 9 and I fly out at about 4, and I just kind of have to chuckle. Yeah, we're not going to quite make that schedule. But anyway, so we're really spread out. The site we're going to see here, if we have them, we don't have to. Whenever you're ready.
Yeah. We're ready. Go ahead and pop the first one up, which is
we have one of our stations. Right there. Let's see. This is actually TDR plot from a network analyzer. A network and TDR all in one.
And you had a problem. I guess you had some reflective power or what?
We had done a relamp on this tower, and the crew when they needed to access to the top beacon and go past the main antenna, we switched to the aux, and all was fine, and ran on it, and they got done in about an hour and called back and said, okay, you can switch back, and we did, and it came up to power and immediately tripped off, and transmitter cycled 3 times and said, I'm done with this. So, okay, that's not quite right.
Let's go back to that first picture, because that's the one.
Let's go back to the TDR plot.
I was talking about the graph.
Yeah.
Now, Patrick, I know enough to know it says TDR, time domain reflectometer, and for those of who may be new to this area, you can take this device, a very expensive device, and through an adapter, you can attach it to the coax down on the ground. And so this expensive device is looking into the coax all the way up to the antenna, and it can send signals up along that and measure what comes back from sending a pulse or some signals up the antenna, up the coax into the antenna. So that's
right.
what we're looking at here. Now,
right.
Across the bottom scale, what are we looking at? The 0, 100, 200? What's that?
All right, at the start, that's where we plug into the 3-inch hard line, and that little blip there is kind of the mismatch with the end of Type 3 adapter. And then we go on up. We're going up across the bottom there is the length in feet. And we start seeing return loss there that we don't like at about 1,040 feet and 1,080 and 1,100. We had 3 or 4 bullets there that were burned up. So
now, all the stuff starting at 1,200 feet, that's
is the
normal.
antenna.
That's the antenna.
Right? Yeah, that's the antenna. That's right.
So a TDR won't help you find a problem with an antenna because its returns are all crazy anyway.
Well, I mean, you can do some stuff with frequency. I think he was using 150 megahertz as the test frequency there, so the antenna was not well matched at that. So certainly not an expert in a network analyzer operation, but I think you might be able to get to maybe in a particular the input transformer or something. I don't know if you're going to be able to look at an individual bay from that input.
So from those blips we saw at just over 1,000 feet, about 1,040. Let's look at picture number 2 now. And you sent the tower crew up and said,
we knew about where it was because of that. So they went up and said, break it apart here, which they did, and that's what we find. And
that stuff's not supposed to be there.
Not supposed to be there. It would run at about 10 kilowatts. It would stay on. That was eventually going to really burn some stuff up, so I didn't run it at any length of time like that. It's like, no, we'll just stay on the aux. But go on to the next one if we can, Andrew.
There it is.
There's that's typical bullet. They've taken the bullet out, and you can see the watch band. You could see it better. This was a screenshot off of the report. You can't quite see inside the inner, the dark ring on the inside, but there's some micro arcing that's occurred there.
All right, what's next then? Next picture.
Pretty nice shot of the Brazos River there in the background. That's what a bullet should look like.
That's a brand new one.
That's either been replaced or a good one.
Okay.
But that's what it should look like.
All right, what's next? Oh,
that's the sticks. We brought them down. You can see how hot it got, and I'll tell you, after copper has reached that point, you can just bend that like a warm candy bar. It's lost its tensile strength. Yeah, it's very soft.
What's next? Let's see the next one. More of the same.
Another end with the bullet in. The bullet normally would have been nice and silvery like that one at the bottom.
And that won't buff right out, I take it.
It will not. This is a little anomaly we saw on the TDR, and they said, hey, looks like you lost a hanger and it's bent your angle here. And these are all under repair, by the way. We're gonna get that butterflies off that 4-inch. I didn't include a lot of the pictures. They did an inspection for me, and we're coming back here in the next couple of weeks and going to clean up a lot of stuff. That there's a lot of maintenance on a tower this size that you have to stay on top of. There's a bolt spring hanger missing a bolt there on the right-hand side, and the river again. And that's probably it. No, we got another one. Oh, that
look
back
at that.
one.
Whoa.
That's looking down. Yeah, that's looking down from near the top. On the one prior to that, there's a spring hanger. It doesn't. It's bent. That one there had some loose flanges, and we actually can see that on the TDR. I think it was around 400 feet or so.
Yeah,
so,
there was a little blip at 400.
I said, go up there and look around 400 and see if you see anything broke or bent or loose. And we did. And looking down, there's that spring hanger.
So this tower has both hardline and flexible coax.
Yeah, the hardline goes to the main, and the flex goes to the aux. This is after we're all done. Things look pretty nice. Yeah. We've got another whole subject, and I'll keep it brief real quick. But we got a problem with vibration on this tower. This tower is short guide. It's only about 30% guide radius, and they didn't install the proper vibration dampers on them. And so we're gonna fix that problem. It may be part of what's exacerbating this with this hardline. It's the only burnup we've had it's 13 years old. And I'm on my second bottle of nitrogen, so this is a remarkably tight transmission line. Both of them are fed with the same bottle, and in 13 years we're on our second bottle. So it's not leaking, and just time and age, things expanding and contracting and whatnot. But a lot of work to keep these places going, and need a good tower and the right tools.
If I was 1,000 feet up in the air outside of Dallas, Texas, in the hot summers and the cold winters you have there, I'd probably blow a gasket too at some point.
Doesn't make things any easier.
We're gonna come back. You're watching This Week in Radio Tech. Our guest is Patrick Parks. He's the chief engineer for Univision in Dallas, and also the founder and president of a wireless ISP in his area on the north side of Dallas. Chris Tobin is with us, and Chris and Patrick will be back here in just a minute with a final word after we hear from our friends at Lavo, who are one of our sponsors. Now, you may or may not have heard of Lavo. L-A-W-O is how it's spelled. L-A-W-O, a German company that's famous for making big, beautiful audio consoles for surround sound, for television remote trucks, for installed sound. They make some beautiful, high-tech, German-engineered consoles. Well, a few years ago, they started making a smaller radio console called the Crystal console. And now they have a new version of that. And this is what we've been talking about here for quite a few months now. It uses a rack mount DSP device that is where all your audio plugs in and your audio outputs are as well. Plus, it has network connections there, including for Ravenna and AES-67. But what's cool is the way you control it. It's a touchscreen controller. In fact, it's a multi-touch touchscreen controller. You can actually touch it with 2, 3, 4, even up to 10 fingers at the same time, moving faders and buttons at the same time on the multi-touch touchscreen controller. Now, the controller is really a PC running Windows 8 and running this beautiful app on top of it. It takes up the whole screen. You really don't know that there's Windows running under there, but you have this gorgeous app that looks like a console, and it looks like a console that's easy to operate. All the controls that you're familiar with are right there. And what also makes it cool is that when you touch one of the options buttons on the console, the touchscreen interface, it's contextual. So it doesn't give you options that don't apply to what you're doing. It's applicable to exactly what you're doing. Therefore, it's easier for operators to make a change a mic gain, for example, pan something left or right, change the back feed for a given source, all these kind of things. The DSP unit is 1 RU high, and it goes anywhere you want. You might have it nearby for local sources, or you might have it back in a rack room if you don't have so much local sources. It connects to the surface, the PC, the virtual surface, via the network. So it's just operating over your Ethernet network there in your studio. in your business. And of course, it has all the things that you would expect a console to have. Program 1, Program 2, a preview channel. There's a separate record bus, automatic mix minusing, precision stereo PPM meters. There's even a panic button that if you as the operator have made some changes and you're not quite sure what you did, no problem. Push the panic button, returns to normal. So you can really get rid of a panic situation pretty quickly. It does have AES EBU digital inputs and outputs, as well as some analog I/O, microphone inputs. Headphone outputs are built into the DSP unit as well. And redundant power supplies are available too. So if you want to check this thing out, let me encourage you to go to Lawo, LAWO.com, and look for the radio consoles and look for Crystal Clear. And then on that page, you're going to find a video that Mike Dosh put together explaining how the Crystal Clear console works. Check it out. I think you're going to like it. If it appeals to you, it's going to appeal to you. They've really done this right. And thanks to Lawo for sponsoring This Week in Radio Tech. All right, guys, just a couple more minutes. Chris Tobin, got a closing thought or question for us?
Oh, I wish I could.
I know this Patrick explains pretty well all this stuff, doesn't he?
Yeah, no, he does. And actually, it's funny because the last couple of months I've been working with an engineering firm doing exactly that kind of stuff on top of rooftops. So I know what he's talking about with the installations and RF work. And I've seen some installs that I'm surprised they're getting a signal out at all. But the RFI EMI stuff you talked about, I did see. I didn't know what that was. So now I know. No, I can't think of anything else at the moment. He did explain it very well.
So, Patrick, I'm thinking that I'm sure there are other engineers, broadcast engineers, who have a little bit of knowledge about this. In fact, I know a guy used to live in Lexington, Kentucky, who was part of building out a wireless ISP in Lexington. He's a broadcast engineer as well. So I'm wondering if there are people watching this show who are interested in, hey, I know a neighborhood that doesn't have any internet service, and my uncle lives there. I'd like to help him out. Where could a knowledgeable person, someone with some broadcast experience, go to learn about how you do this, as long as they're not in the northern Dallas area? Where can somebody go to figure this? If they're in that area, call you. You'll help them out.
Yeah, there's lots of resources. I go to ubnt.com, Ubiquity Networks. They've got forums. They've got good wikis on their equipment and stuff that's available. The Wireless Internet Service Providers Association, WISPA.org. At least have some links to some organizations or some resources. If you're already in broadcast engineering, it's half the battle. I mean, you're not going to be afraid of this cable, plug it in here, and what's it going to do? Most of us, what do? We just hook it up, and then when we get stuck, we get the book out. So.
You're so right.
I mean, not all of us. I know guys that are some really smart guys that will read the book before they ever open the box, and I've done that a little bit or a time or two. But I wouldn't just say just Google. I would start with those tools. Although you could do that as well. There's some, just like anything on the internet. There's a lot of junk out there, and there's people that tell you stuff that's flat out wrong. And
my experience with UBNT, and I own some of their gear. These guys want you to know how to use their gear, so they're going to do a good job of explaining it. And WISPA, the Wireless Internet Service Providers Association, WISPA.org.
Correct.
Good couple of places to start with. Hey, guys, we're out of time. Patrick, thank you so much for taking an hour. And I know the prep time you put into this was not insignificant. So
well, I'm happy to do it. I was looking at your list of people before that, your previous shows, and there's quite a list of notables there. So this is like being inducted into some Hall of Fame.
We'll come back anytime. We'll have free hot dogs and balloons for the kids. So.
Excellent.
Hey, and will you be at NAB or not?
I am scheduled. I've made my reservations, but that's always subject to change. Something could catch on fire. But I do have my reservations. I am scheduled. So maybe we'll see you there.
Well, if you're there, I hope to see you there. And
Excellent.
Chris Tobin. Chris Tobin has been with us from Manhattan. Chris, thank you for being with us. And if people want to get in touch with your IP codec consulting business and get some of your expertise in solving their problems, where will they find you?
They can find me at support@ipcodex.com. That's ipcodexplural.com. And here's my M5 bullet for Ubiquity.
Oh, yeah.
One of my little toys I've been... I'm actually going to be using it this weekend for the sports remote that I told you about.
Lot of bang for the buck in that little thing. It's
Oh
like
my goodness, I've got a couple of these.
$49 or
It's
something?
great. Yeah, it's 40, 50, somewhere on there. Yeah, it's great.
And is that standalone, or does that fit into a parabolic reflector?
Oh no, this is a standalone. I can put a little little antenna on this or a cable, and then off I go. I do have another one that is a integrated all in the antenna. I have a radio waves dish that I use, and I plug it in the back.
Cool. Good deal. Good deal. All right. And hey, guys, that's it for us. We're out of time. I want to thank Andrew Zarian for producing our show. Thanks so much, Andrew, and thank you for helping us get it distributed to everybody out there. If you would, if you like the show, subscribe to it. Subscribe. It'll come into your device, your PC, your iPod, your phone, whatever you got. It'll come in automatically, and you won't have to worry about downloading it. It'll just be there when you have time to listen to it or watch the show. You can get it on iTunes and any of your popular aggregators. So thanks for all that. Patrick Parks and Chris Tobin, thanks for being with us. Andrew, thank you. And we'll see you next week on This Week in Radio Tech. Bye-bye, everybody.